Hope you guys did well on your quiz. Continuing on. So let's talk about the quadratic formula. Second strategy that you can use to solve a quadratic equation to find the roots or the zeros or the x-intercepts depending on the directions that are given to you. So still the same section. Oh man, I recalibrate this thing all the time and it's still sucky. Section 2.5, still on solving, but our focus today is solving using the quadratic formula. Okay, so we can use this method on any quadratic that's in standard form, and it's going to have a b term. So with square roots, you couldn't solve it if it had a b term, but these standard form ones could have b terms. And the formula should look familiar when I write it down. Before you apply the formula, you've got to make sure that the equation is set equal to 0. That's different than solving by square roots. Okay, so we can use this to solve any quadratic in standard form that you have to set equal to 0. So you might have to do some work to get it equal to 0 first, and then once you're set it equal to 0, you can apply this formula. So I'm going to write it on the board. I'm going to sing you a really corny, silly song that even students have come back from college to tell me that they remember the formula because they were singing the song in their head. So yes, it might be annoying. You might have heard it before, but it can help students remember what the formula is. So it's negative b plus or minus the square root. Underneath the square root, it's b squared minus 4ac all over 2 times a. That's the formula. So you're going to be subbing in the a, b, and c from standard form into this formula, and that will tell you what x equals. It'll tell you your roots, your solutions, your zeros. So here's the song. It goes to, I think it's like that childhood nursery rhyme, the all around the mulberry bush or the monkey chased the weasel. I don't remember, something like that. But it goes, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Normally, I would then make you guys repeat it like 3 times with me, but I'm not here to make you do that. The sub might make you do it, might not, but I think it's worth trying to sing on your own. So I'm going to do it again, and you do it with me if you want. So it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, let's try and apply it. Okay, we're going to leave all of our answers in radical form and simplify at the end as far as we can using the way we talked about simplifying at the end of class yesterday. So we did that worksheet at the end of class that talked about simplifying the results of the quadratic formula. So here's example number 1 that we are going to go ahead and solve and find the roots. So 3x squared plus 5x equals negative 4. Okay, I'm going to set it equal to 0. So I'm going to add the 4 over. This is unlike the square root method. In the square root method, you're trying to get everything away from x. You're not doing that with this strategy. If it helps you, off to the side, you could actually write what your a, b, and c values are. So we have 3, 5, and 4. And we're going to now sub those into the formula. And I'm going to sing the song while we do it. So it's going to be x equals negative b plus or minus square root b squared minus 4ac all over 2a. Easy part is subbing them in. The hard part is now simplifying that down without making any mistakes, including sign mistakes. So take your time. This is going to become negative 5 plus or minus the square root. Under the radical, you're going to square and then multiply your 4ac. So 5 squared is 25. If this was a negative 5, you'd have to be careful. That would affect your sign. And then I like to look at the 4ac and count my negatives. I only see 1 negative there, so my answer is going to stay negative. If you see 2 negatives, it's going to change to a positive. And if you see 3 negatives, it'll stay negative. Okay, so there's only one negative, that first -4. Negative times a positive stays negative. And if I multiply those 3 numbers, 4 times 3 is 12, times 4 more is 48. This is over 6. I'm going to get -5 plus or minus the square root. I'm going to do my subtraction of 25 minus 48 and get -23 over 6. Once you get down to the radical, there's always 3 options with the radical. Either the number stays in, the number comes out, or you try to break the radical apart. 23 is not a perfect square, so it can't come out. And there is no perfect square that goes into 23, so you can't break it apart. The only thing you can do is take the negative out as I. So my final answer is going to be -5 plus or minus I radical 23 over 6. You can look at to see if each term has something in common. We have a 5, a 6, and technically that would be a 1 in front of the radical 23, and there's nothing that goes into all of those. So those are your answers. We end up with 2 imaginary solutions. One of them would be -5 plus I radical 23 over 6, and the other would be -5 minus I radical 23 over 6. All right, let's do, we have 2 more, and then a real world plan. So example number 2, 4x squared plus 8x equals x squared plus 35. I have 2 terms on the left, 2 terms on the right. When you're trying to decide which side to move them all to, there's less chances for you to make mistakes with the formula if you keep your a value positive. So to keep the a value positive, you want to move the smaller x squared. Sometimes that means moving more terms than necessary, but it also means less chances for sign errors when using the formula. So if I want to keep the a value positive, I'm moving everything to the left. Because when I subtract the x squared, I'll get positive 3x squared. That'll be a positive a value. So subtract the x squared and subtract the 35. The 35 will not be like terms with anything. It'll stay separate. So we get 3x squared plus 8x minus 35 equals 0. Once it's equal to 0, we just sub everything into our formula. Singing the song. X equals -b plus or minus square root b squared minus 4ac all over 2a. Okay, subbed everything in. Simplify it down. I would pause it, see if you guys can try to go from here and check your answer with mine. Okay, I'm going to get -8 plus or minus the square root of, when I square my 8, I get 64. Here I'm going to count my negatives, and I see 2 negatives. So a negative times a negative means my sign will change to a plus. 4 times 3 is 12. And then I have to do 12 times 35, so it's going to be a larger number. 12 times 35 is 420, all over 6. Keep combining under the radical. That's going to give me the square root of 484 over 6. Now, with the last example, I said when you have a radical, there's 3 options. Stays in, comes out, or you break it apart. Before you try to break it apart, when it has larger numbers, always check to see if it's already a perfect square. Just for the heck of it, I'm going to try to square root 484, and I get 22. So this is a perfect square, just not one you're familiar with. So we're going to get -8 plus or minus 22 over 6. There's no radicals left, no imaginaries anywhere. So when that happens, I need to get 2 exact distinct values. So I will do -8 plus 22 over 6 and -8 minus 22 over 6. I'm separating the plus and the minus to be able to do out my math. And the first one, when I do -8 plus 22, I'm going to get 14 over 6, which stays a fraction. I can divide them both by 2 to get 7/3. And the second one, -8 minus 22, is -30 over 6, which is -5. So my two solutions are 7/3 and -5. Okay, that's two real solutions. Okay, so the first example, we got two imaginary. This time we got two real. The time where you get the one solution or the one repeated, counting twice, would happen if you had the square root of 0. Because if you had the square root of 0, positive 0 and negative 0 would be the same thing. You'd only end up with one distinct solution, but it would count twice. Here's our last skill-based one before we try a real world. So negative x squared minus 2x equals 2. Normally, what I would say in an example like this is to prevent errors, I would say move everything to the right. That would give you a positive a value. But because I know you're not always going to end up with a positive a value, I want you to see what happens when the a value stays negative, because it can look a little more confusing. So I'm purposely going to move everything to the left, but if I gave this to you to do on your own, I would say move everything to the right. It's also a good example because this is our first one that has a negative b value, and we haven't had one of those yet. So we're going to move everything to the left side. We'll get negative x squared minus 2x minus 2 equals 0. And I would pause, try the formula on your own, and check with mine. So x equals negative b. In this case, my b is already negative, and the formula is negative. That means it's going to turn to a positive here, because negative 2 is positive 2. Plus or minus square root b squared minus 4ac all over 2a. And take our time, make sure we execute this properly. 2 plus or minus the square root. Here's a huge area that students make mistakes when they square that negative. Because if you do that on a calculator and don't put parentheses, your calculator will tell you that negative 2 squared is negative 4. That is wrong. When you square a negative, this first term should always, 100% of the time, be positive. Okay, because you're squaring the negative as well, which is why I put parentheses around the negative. So it should be a positive 4, not a negative 4. Then I have 3 negative, oops, can't circle that, 3 negatives here, calibration's off. 3 negatives stays negative. 4 times 1 times 2 will be 8. And then I'm going to have a negative 2 in the denominator. Keep going, I'm going to get 2 plus or minus the square root of negative 4 over negative 2. Once you get down to the radical, decide whether it stays in, comes out, or you break it. This is going to come out. The square root of 4 is 2. So you're going to get 2i over negative 2. And then once you get here, you can look to see if there's something in common between all your terms, which there is. And because the denominator is negative, I'm going to divide everything by negative 2. That'll give me negative 1 plus or minus 1i over positive 1. Okay, it's still going to be a plus or minus sign, because when you do positive 2 divided by the negative, you'll get a negative. And then negative divided by a negative is a positive, so you still have one of each. And when you divide the denominator by negative 2, you get positive 1. You don't have to write positive 1 in the answer. And this is, again, two imaginary solutions. One of them would be negative 1 plus I. The other would be negative 1 minus I. That's the quadratic formula. Should sound familiar. It is something that you would have learned in Algebra 1. Okay. I'm going to set up a real-world problem for you. And last year, I was not able to finish this on day 3, so this may need to be finished tomorrow in class, depending on how quick you guys were able to do the quiz and those last 3 examples. So I'm going to write it down now, and you might have to pause and come back and finish it during class tomorrow. And tomorrow you're going to work on a quadratic formula practice sheet to make sure you can apply it correctly. So here's our real world example. Sorry. I got to give you a formula first. So this is the formula that we would use if you are throwing an object. So unlike the one from yesterday where an object was falling, these are going to have force behind it. Okay, so this is, I guess you could call Oh my goodness. Pause the video. I'm recalibrating. This is like the third time I've done this in a row. Okay, here I go, try that again, and it's not much better. Okay, so you could, I guess you could call it like a throwing, that says object. Object formula. It's going to look very similar to the following object, but it will have a B term, it'll have a middle term. So it'll be h of t, so the height of the object as it's thrown or kicked or projected or shot, okay, something with force behind it, will be negative 16t squared plus v naught times t plus h naught. So the only difference is this middle term right here, which will be the velocity of the object, the speed of the object, essentially. So that is a different component. So when you're throwing something, it has some force behind it. It'll have some speed. So that's why we have a middle term. So we're going to use this formula to do this example. So there's a powerful crossbow that's going to fire a bolt straight upward from a deck that is 10 feet off the ground with an initial velocity of 320 feet per second. We're going to figure out when that bolt from the crossbow will hit the ground. So some key information that we're going to write down. Okay, so the deck is 10 feet high. The initial velocity was 320 feet per second. And I want to know when will it hit the ground. So if you wanted to write down the fact that we're firing from a crossbow, I guess that would be also some useful information, so that way this question doesn't come out of nowhere. Okay, when will it hit the ground? So we're going to set up our model. So h of t is going to equal negative 16t squared plus the velocity comes next. So it'll be 320t plus the initial height. So it's starting from a height 10 feet off the ground on the deck, so plus 10. We're now going to input these numbers into the formula, and we're going to be working with decimals. You do not need to leave your answer in radical notation. Decimals are okay. Hitting the ground means we're going to have 0 here. I cannot solve this by square roots because of the velocity term, that middle term. We have to do the quadratic formula. So it'll be x equals, but the t is in x's location, so it'll be t equals x equals negative b plus or minus square root b squared minus 4ac all over 2a. Don't you love my beautiful voice? I wish I could sing. But I'll still do it for you guys if it helps you memorize that song and helps you memorize that formula. Here we go. Simplify it down. Negative 320 plus or minus the square root. I'm going to square 320, and yes, it's going to be a large number. 320 squared is going to be 102,400. I have two negatives with the 4ac, so it's going to change to a plus sign. 4 times 16 is 64, and 64 times 10 is 640. Okay, 4 times a times c, all over 2 times a, which will become negative 32. Keep going with it. If I do 640 times the, or not times, plus the 102,400, you get 103,040. And here's where real world's different than non-real world. If it was not a real world, I would say try to break apart the 103,000. Because it is real world, I'm going to say square root that no matter what, even if you get a decimal. So if I square root that number, I'm going to try not to round yet. Remember, the sooner you round, the less accurate your final answer will be. Okay? And now that there's no radical or no I, you should be able to split this problem up into two separate expressions. So we'll have negative 320 plus that number. And I'm going to round on paper, but when I'm doing this on the calculator, I'm using that whole number. I'm just feeling a little lazy right now and don't feel like writing it all down on the paper. On the calculator, I'll use the whole thing. Okay, so I set up 1 plus, 1 minus. I broke them apart, and I'm going to combine. In the top, negative 320 plus the 320.998 is just going to be the 0.998, etc., over negative 32. And if I divide by negative 32, I'm going to get approximately negative 0.031 seconds. The second one, negative 320 minus 320.998, etc., is going to give me negative 640.998, etc., over negative 32. And if I divide those, I'm going to get 20.031 seconds. Only one of these makes sense. So we're trying to figure out how long until that bolt shot from the crossbow hits the ground. It should not take a negative amount of time for it to hit the ground. So the answer, even though I wrote both of them down, I'm going to put a box around the one that actually makes sense. So it'll take a little over 20 seconds for it to hit the ground. Okay. So before I have you guys work on the practice worksheet, I really want to just emphasize when you're reading a real world problem, because eventually these are going to be mixed up with like the vertex ones, you have to think about what part of the parabola it's asking for. All right, so in these velocity examples, you have an object that goes up and then comes down again because it's thrown with force or shot with force. So if I said, where is it going to hit the ground? Okay, that is referring to solving for x. If I said, what's the maximum height of the bolt that is shot from a crossbow? That would be referring to the vertex if I asked for the max height versus the ground. I could have also said, find the time. This is, remember, 10 feet because it started 10 feet high. I could have said, find out how long it took for it to reach a height of 13 feet. Okay? That would happen at two locations because it would hit 13 feet on the way up and 13 feet again back on the way down. Even though those are not on the x-axis, these are still, that's supposed to be an arrow. These are still considered the roots. Okay, you're still trying to find those two x values by the quadratic formula. All right, even though it's not on the ground, you're still solving for x. This would essentially be 13 equals your equation, and you would solve that equation. Once you set it equal to 0, it's like imagining taking this parabola and shifting it down onto the x-axis to turn the 13 into a height of 0, because you end up moving the 13 over. All right, so you guys have the remainder of class to go ahead and work on the quadratic formula practice worksheet. Tomorrow, and you have homework on it as well, and tomorrow you guys are going to go ahead and learn the final way of solving, which is really nothing new at all. It's a combination of skills you already know, plus we'll learn how to figure out how many solutions exist without actually solving anything. All right, so two main goals for tomorrow's class. Talk to you later.